Right now, beneath nearly 2 miles of ice, a river longer than the Hudson is flowing in complete darkness. Scientists just found it. What they discovered changes everything we thought we knew about Antarctica. Because the ice isn't frozen solid, it's bleeding from the inside out. Antarctica. The name alone conjures images of endless white, pristine emptiness. A frozen wasteland where nothing moves, nothing changes, nothing lives. For decades, scientists believed it too. The continent was a giant ice cube, static, predictable, dead. They were catastrophically wrong. In 2022, researchers flew a routine radar survey over West Antarctica. But this time, the data made them stop mid-flight and stare at their screens in disbelief. The radar had found water, not just a puddle, an entire river system, active, flowing, stretching for over 286 miles beneath the ice sheet, a river hiding in the dark. To see through nearly 2 miles of solid ice, scientists use ice-penetrating radar. They mount it on aircraft and send radio waves straight down through the ice. When those waves hit something different, rock, sediment, or water, they bounce back. The return signal builds a three-dimensional map of everything beneath, without drilling a single hole. It is like having X-ray vision through ice. The researchers were not looking for rivers, they were mapping bedrock. But as they analyzed the data, they noticed something strange. A long, continuous channel carved into the bedrock, and inside it, a signature that could only mean one thing: liquid water, flowing liquid water. The main channel stretched 286 miles, longer than the Hudson River. But this was not some shallow stream. This thing was flowing under pressures that would crush a car, in temperatures hovering just barely above 32 degrees Fahrenheit, in complete darkness. And it had been there the whole time, hiding. They called it a subglacial river, a river flowing along valleys carved millions of years ago when Antarctica had forests and rivers and life. Now those ancient valleys serve as highways for meltwater generated by geothermal heat from Earth's interior and the immense pressure of billions of tons of ice above. A massive river flowing in pitch darkness, under more pressure than the deepest ocean trenches, along a landscape that has not seen sunlight in millions of years. But here is where this becomes urgent. Ice sheets flow, pushed by their own weight toward the ocean, but their speed depends on friction between the ice and the bedrock below. Think of it like sliding a heavy box across a floor. A dry floor gives maximum friction. Pour water on that floor and the box glides. The water lubricates it. Same thing happens with ice sheets. Where the base is frozen to bedrock, ice moves slowly. But where there is water below, everything changes. The ice slides faster, much faster. These subglacial rivers create lubricated highways that allow enormous sections of ice to accelerate toward the ocean. Water flows from inland areas, travels through channels toward the coast, lubricating increasingly massive areas of ice as it goes. It is a chain reaction. More water means faster flow. Faster flow means more ice reaching the ocean. More ice in the ocean means rising sea levels. Here is the terrifying part. Previous models treated subglacial water like isolated pockets, disconnected lakes. The models assumed water could not move efficiently beneath the ice. The discovery of these river systems proved those models wrong. Water can move. It can spread. Ice sheets can accelerate far faster than we thought possible. Every prediction about sea level rise was based on the assumption that subglacial water could not flow like this. And now we know it can. Let's talk about Thwaites Glacier. Scientists call it the Doomsday Glacier. That is not media hype, that is what researchers actually call it. Thwaites is roughly the size of Florida, and it is collapsing. If Thwaites fully collapses, it will destabilize the entire West Antarctic Ice Sheet, potentially raising global sea levels by over 10 feet. 10 feet. Miami completely submerged. New York financial district underwater. Boston, New Orleans, Houston, San Francisco are all facing catastrophic flooding, and that is just in the U.S. Preliminary radar data suggests subglacial rivers exist beneath Thwaites as well. The glacier is not just melting from above, It is being lubricated from below, accelerating its slide toward the sea. This is the nightmare scenario, and it is happening now. But there is more. When researchers started mapping these rivers, they stumbled onto something else. Life in the dark. In 2013, scientists drilled into Lake Whillans, a subglacial lake in West Antarctica. They expected sterile, dead water. After all, this water had been sealed beneath miles of ice for hundreds of thousands of years, cut off from sunlight and oxygen. Instead, they found nearly 4,000 species of microorganisms, an entire ecosystem, thriving. These were not familiar bacteria. They were extremophiles, organisms adapted to survive in environments that would kill almost anything else. No sunlight, no photosynthesis. They extract energy from chemical reactions. They break down minerals in the water. They metabolize compounds in the bedrock itself. They have evolved to live in perpetual darkness, crushing pressure, and temperatures right at the edge of freezing, just above 32 degrees Fahrenheit. Life operating under completely different rules. Now here is where it gets stranger. These lakes are not isolated. They are connected by rivers. And that raises a simple question. Are these ecosystems connected too? Do organisms flow between lakes through the rivers? A hidden subway system for life beneath the ice? Nobody knows yet. But the implications are staggering. Some scientists call these environments analog sites for extraterrestrial life. Because if life can persist in Antarctica's darkness, similar ecosystems might exist elsewhere in the solar system. Europa, Jupiter's moon, is covered in ice. Beneath that ice, there is an ocean, dark, cold, and pressurized. Sound familiar? Enceladus, Saturn's moon, has a similar setup, an icy shell with a subsurface ocean. If life can thrive beneath Antarctica's ice, maybe it can thrive there too. NASA is designing missions right now to explore these icy moons, using what we have learned from Antarctica as a blueprint. The subglacial lakes and rivers beneath the ice are not just important for understanding Earth, they are a window into how life might exist on other worlds. But back to our planet, because there's still so much we don't know. Antarctica is Earth's largest remaining unexplored frontier. We've mapped Mars in higher resolution than the bedrock beneath Antarctic ice. These rivers flow through ancient valleys, mountain ranges, possibly active volcanic systems. Every new radar survey uncovers more surprises, more channels, more lakes, more connections. It's like discovering an entire hidden world right here on Earth, a world operating in secret while we lived on the surface, completely unaware. But this hidden world isn't just a curiosity, it's actively shaping the future of our coastlines. These rivers accelerate ice flow. The more we discover, the more we realize ice sheets can respond to changes over decades, not centuries. And here's the unsettling part. We don't have complete maps yet. We don't know where all the rivers are. We don't know how much water they're moving. We don't know if the network is expanding as the climate warms. We're flying blind, making predictions based on incomplete data. And every time we learn something new, those predictions change. Usually they get worse. Understanding how water flows beneath the ice directly affects how accurately we can predict sea level rise. And sea level rise affects billions of people. Coastal cities need to know whether they have 50 years to prepare or 15 years. From Los Angeles to Charleston, from Seattle to the Florida Keys, insurance companies, infrastructure planners, and disaster response teams are all making decisions based on projections that depend on understanding ice sheet dynamics. And those dynamics are controlled by water we cannot see. Antarctica is bleeding from the inside out. That is not poetic exaggeration. It is literal. Meltwater is flowing through channels in the bedrock, lubricating the ice sheet and accelerating its movement toward the ocean. The ice is moving faster than we thought. The timeline is shorter than we hoped, and the consequences are irreversible. Once an ice sheet starts sliding faster, it is hard to stop. Once glaciers like Thwaites destabilize, they do not snap back. The feedback loops all push in the same direction. Faster, faster, faster. But understanding these subglacial rivers tells us where we need to focus attention, which glaciers are most at risk, which regions are most vulnerable, and where intervention might actually make a difference. Maybe we cannot stop Thwaites from collapsing, but understanding the mechanisms means we can make better predictions, plan better responses, and adapt more effectively. The discovery of Antarctica's hidden rivers isn't just a scientific breakthrough, it's a warning. A glimpse into systems we didn't know existed, operating on scales we didn't comprehend, with consequences we're only beginning to grasp. This isn't some distant apocalyptic scenario. This is happening right now, beneath the ice, in the dark, while we go about our lives completely unaware that the ice is shifting beneath our feet. And the most unsettling part? These rivers have probably been there for thousands of years. We just didn't know to look for them. Which raises an obvious question. What else is down there that we haven't found yet? What other systems are operating beneath the ice that we're blind to? What other feedback loops are already in motion? What other surprises is Antarctica hiding? The ice doesn't give up its secrets easily. Every answer raises 10 new questions, but one thing is crystal clear. Antarctica isn't the frozen, static wasteland we thought it was. It's dynamic. It's complex. It's alive with movement and processes we're only beginning to understand. And it's changing. Fast. The rivers are flowing. The ice is moving. The clock is ticking. And the world's coastlines are watching. Subscribe to GeoPulse to explore more hidden systems shaping our planet.